Hello everyone. Our next question is find the angle between two diagonals of a cube. So in this chapter there are two cube questions. They are very important. Practice it well. It will come in your examination. Okay. So let O be one of the vertices of the cube be taken as the origin and the three edges OA, OB, OC are coordinate axes. So in a cube we have O as the origin, OA, OB, OC are the coordinate axes of x, y and z. Okay, they are the vertices of the cube. O will be the origin, so it is 0 comma 0 comma 0, and we have taken the side of the cube is equal to a units. Okay, so these vertices you need to remember: a, b, c, d, e, f and g. Okay, there are four diagonals of the cube that are OG, AE, BF and CD. In order to find the diagonals angle between the diagonals, we need to find the dias of any two diagonals. So I'll find the dias of OG and AE. So we'll get the values of A1, B1 and C1 and A2, B2 and C2, and we will substitute in the cos theta formula. Okay, so dias of OG is equals to, will minus G minus O, vertices of G minus O. So G is A comma, sorry, A minus 0 comma A minus 0 comma A minus 0. So it will be A and A. So these values will be A1, B1 and C1. Similarly, dias of AE can be given as E minus A, vertices of E minus A. So it will be 0 minus A comma A minus 0, and again it is A minus 0. So this will be minus A and A. So it will be A2, B2 and C2. Okay. Now we have got the values of both. So we'll write if theta be the angle between diagonals of the cube OG and AE, then the formula is cos theta is equals to mod a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. So it will be cos theta equals to, the value of a1 is a, so it is mod of a into a2 is minus a plus b1 is a, b2 is also a, plus c1 is a, c2 is also a, by root of a square plus a square plus a square into, here also a square plus minus a square plus a square plus a square. So here it is minus a square and it is plus a square, so they get cancelled. So it is cos theta is equal to mod of a into a is a square, by, here we will add a square plus a square plus a square is root of 3a square into, here also same, root of 3a square. So for the a square and root will get cancelled. Okay, for a, for root 3 it will be there. So it is mod a square by root 3a into root 3a, that will be equal to a square by root 3 into root 3 is 3, a into a is a square gets cancelled. So we are remaining with 1 by 3. So cos theta is equal to 1 by 3. So cos goes there, so it is theta is equal to cos inverse 1 by 3. This is the angle between the two diagonals of the cube. Next question is, if a ray makes angle alpha, beta, gamma, delta with the four diagonals of a cube, then show that cos square alpha plus cos square beta plus cos square gamma plus cos square delta is equals to 4 by 3. Okay, so we have to write all this first. Let O be the one of the vertices of the cube taken on the origin and three edges be OA, OB and OC as coordinate axes, right? OA, OB, OC are coordinate axes, and the side of the cube is taken as A. and you have to remember all the vertices of the cube. The four diagonals are taken as OG, AE, BF and CD. Okay, now we have to find the angle between the four diagonals, okay, of the cube. So we know the four diagonals as OG, AE and BF and CD. So we'll find the direction ratios, then we'll find the direction cosines, then we'll substitute in a cos formula. Okay, so drs of OG bar is given as will minus G vertices minus O. So you will get it. So it is A minus 0, comma A minus 0 and A minus 0. So this can be written as A comma A comma A. Now dividing by root of, this is A, B and C, right? So it is A square plus A square plus A square. So this will be 3 root 3 A square. For A the square and root gets cancelled. So it is root 3 A. So the DCs of OG are A by this, right? If you remember the formula, you can write this A by root 3A, comma A by root 3A. I have explained in the last videos. We'll cancel 1 by AA, so it is 1 by root 3 comma 1 by root 3 comma 1 by root 3. We got the values of DCs of OG. Similarly, we have to do for more 3 points of the diagonals. Okay, so DRs of AG bar can be given, AE bar can be given as E minus A. We have to subtract vertices of E and A. So it is 0 minus A, comma A minus 0 and A minus 0. That will be equal to minus A and A. Now this will be same for all the diagonals, this condition, okay, dividing, because we'll all get A and A with one negative and another positives. So it will be same, root 3A. So DCs of AE bar can be given as minus A by root 3A, comma A by root 3A, comma A by root 3A. Cancelling A, so we will get minus 1 by root 3, comma 1 by root 3, comma 1 by root 3. Now drs of BF bar is equals to F minus B. So it will be A minus 0, 0 minus A minus 0. So this will be equal to A comma minus A comma A. DCs of BF bar can be given as A by root 3A, comma minus A by root 3A, comma A by root 3A. So A gets cancelled. So it is 1 by root 3, comma minus 1 by root 3, comma 1 by root 3. Okay. Next are drs of CD. So drs of CD can be given by D minus C. So it is A minus 0, A minus 0 and 0 minus A. Okay. So this can be written as A comma minus A. So DCs of CD can be given as A by root 3A, comma A by root 3A, comma minus A by root 3A. So A gets cancelled. So it is 1 by root 3, comma 1 by root 3, comma minus 1 by root 3. So we got the values of all DCs of the diagonals. So next step is let the direction cosines of the given ray be L, M and N. If this ray makes the angle alpha, beta, gamma and delta with four diagonals of cube, then the formula is cos alpha is equals to mod L1 L2 plus M1 M2 plus N1 N2. L, M and N are the values of L1, M1, N1 and OG. Alpha makes the angle with the diagonal OG. So OG values are 1 by root 3, 1 by root 3 and 1 by root 3. So this will be L2, M2, N2. Substituting here, so it is cos alpha is equals to mod of L into 1 by root 3 plus M into 1 by root 3 plus N into 1 by root 3. So this will be equal to cos alpha is equals to L by root 3 plus M by root 3 plus N by root 3. So we can write it as whole L plus M plus N by root 3 is the value of cos alpha. Similarly for cos beta, gamma and delta, cos beta can be written as AE. So it is minus 1 by root 3. So minus L will come. Minus L plus M plus N by root 3. Cos gamma is equals to, for gamma it is in the middle is the minus, so it is M value. So it is L minus M plus N by root 3, and cos delta is equal to L plus M minus N by root 3. Now in the question we have to prove that cos square alpha plus cos square gamma plus cos square beta and cos square gamma plus cos square delta values. Substituting the value of cos alpha, cos beta, cos gamma and cos delta from above in this equation, so we'll get L plus M plus N whole square by, for root 3 the square and root gets cancelled, so it is only 3, plus here it is minus L plus M plus N whole square by 3 plus L minus M plus N whole square by 3 plus L plus M minus N whole square by 3. Here 1 by 3 will take as common. Now applying the formula of A plus B plus C whole square. So it is A square plus B square plus C square and plus 2LM plus 2MN plus 2NL. Right? This is for the first term. Plus second term is L square plus M square plus N square minus 2LM plus 2mn and minus 2nl plus L square plus M square plus N square minus 2lm minus 2mn plus 2nl plus L square plus M square plus N square plus 2lm minus 2mn and it is minus 2nl. So here plus 2lm minus 2lm plus 2mn minus 2mn and plus minus and plus, again it is minus and plus and plus and minus, all gets cancelled, so we'll be remaining with L square, L square, L square and L square. So there are 4 L squares. Similarly there are 4 M squares and N squares. Taking 4 common, so it is 1 by 3, 4 common, so it is L square plus M square plus N square. the value of this term is equal to 1. So it will be 1 by 3, 4 into 1, that is equal to 4 by 3. So the last LEQ of this chapter is find the direction cosines of two lines which are connected by the relations L minus 5m plus 3n equal to 0 and 7l square plus 5m square minus 3n square equals to 0. So we should find the direction cosines, DCs, okay? So first we should find the direction ratios, then we'll get direction cosines. So given relation, first equation is L minus 5m plus 3n equal to 0. Equation 1. From here we'll get the value of L is equals to 5m minus 3n. And equation 2 is 7l square plus 5m square minus 3n square equals to 0. Substituting the value of L here, so it will be 7 into 5m minus 3n whole square plus 5m square minus 3n square equals to 0. Now applying a minus b whole square formula, 7 into 25, 5 5 the 25 m square plus 3 3 the 9 n square minus 2 into 5 into 3 is 30 mn plus 5m square minus 3n square equals to 0. Multiplying 7 inside, 25 sevens are 175 m square plus 7 nines are 63 n square minus 7 threes are 21 and this 0 as it is, mn plus 5m square minus 3n square equals to 0. So 175 plus 5 is 180, so 180 m square minus 210 mn. 63 minus 3 is 60 plus 60 n square equals to 0. Taking 30 as common, so it will be 6m square minus 7 mn plus 2n square equal to 0. So we'll be remaining with 6m square minus 7 mn plus 2n square equal to 0. 7. So this is 6 to the 12. 12 factors are 4 and 3. So it is, they are the factors minus 4 mn minus 3 mn plus 2n square equal to 0. So we'll take 2m common. So it is 3m minus 2n minus n, 3m minus 2n is equals to 0. So one factor is 3m minus 2n and another factor is 2m minus n equal to 0. So our third equation becomes 3m minus 2m equal to 0 and 2m minus n equal to 0. This is equation 3 and this is equation 4. Now we'll solve 1 and 3. So the equation 1, it is, we'll start from the coefficient of m. So it is L, m and n. So it is minus 5, 3, minus 5, 3, 1 and minus 5 again. Equation 3, m value is 3, n is minus 2, no L, so it is 0 and again it will be 3. So we'll get L by 10, 5 2s are 10, minus 3 3s are 9 equal to m by 0, 3 into 0 0 and this will be plus 2, 2 1s are 2 equal to n by 1 3s are 3 and it will be 0. That is L by 1 is equals to m by 2 is equals to n by 3. So we got the DRs of the first line. First line are 1, 2, 3. Right? Now to get the DCs, divide by root 1 square plus 2 square plus 3 square. So it will be root 14. So we'll get DCs of first line can be given as 1 by root 14, comma 2 by root 14, comma 3 by root 14. Now similarly we need to solve for 1 and 4. Solve 1 and 4. So it is L, M and N. From the middle we'll start from the equation 1. So it will be minus 5, 3, 1 and minus 5. And for here M value is 2, N is minus 1, no L, so it is 0. And again it will be 2. Multiplying 5 ones are 5, negative, negative, positive, and minus 2 threes are 6 is equals to M by 0 plus 1 is equals to N by 1 twos are 2 minus